Hello.
Yes, sir. Good evening, sir.
Good evening. Very good. So, have you doubted the last lecture? Everything fine now?
I'm sorry, sir.
Have you doubted in the last lecture?
No, sir.
Everything fine now?
Yes, sir.
Okay, okay. Thank you. So, so, so today discuss one important point. 1 minute, beta, 1 minute. Yeah. Okay. So today I will discuss next thing. Co-prime number. Okay. That is the very basic thing. So, two natural numbers. Two natural numbers, but the condition is that not necessarily prime, not necessarily, not necessarily prime. So that is the condition. Two natural numbers, not necessarily prime, are called are called are called co-prime, are called co-prime if their HCF if their HCF is 1. Okay. So that is very basic and elementary condition here about the four prime numbers, two natural numbers. The thing is that here the natural numbers not necessarily prime. Okay, so it is not the condition here it should be always prime. No any condition here. Simple thing is that beta two natural numbers are called co-prime if their SCF is 1. Okay.
Yes, sir.
Hmm. The SCF is highest common factor. Highest common factor, and you can say that, or GCD. Okay, means what? Greatest common divisor. Greatest common divisor. So, Ajay, have any idea? Do you have an idea to find SCF? Do you know something about SCF?
HCL, sir.
Do you know something about HCF?
Yes, sir.
Okay, so here fundamental example is, let's say 1 2 1 3 3 4 3 4, let's say 310 310, okay, 3 8 5 6 7 8 15 16, etc, etc. So these all pairs are co-prime because their SCF will be 1. Okay. One important thing is that these numbers are these numbers are also called these numbers are also called as relatively prime. Relatively prime numbers. Okay. So these numbers are also called as relatively prime numbers. So that is the formal definition about the co-prime number. So basically, some important point is here. Okay. So I will discuss with you some important point. Okay.
Yes, sir.
This is note point. So first thing is that two prime numbers, two prime, two prime numbers are are always co-prime. Two prime numbers are always co-prime, but but converse need not be true. So fundamental thing is that beta, the two prime numbers are always co-prime numbers, but their converse need not be true. Okay. And second thing is that consecutive consecutive natural numbers, consecutive natural numbers are always are always always co-prime, are always co-prime numbers, are always co-prime numbers. Okay. So that is the basic and formal definition about the co-prime numbers. So I think this is better clear to all. No need to any explanation here. Just tell me. Okay.
Okay, sir.
Okay. Just better note it.
Yes,
Note
sir.
it down.
Yes, sir. Yes,
Better.
sir.
Done.
No, sir. I'm still writing it down. I'll tell you when I'm done.
Hmm?
Yes, sir. I'm done.
Number system chart. Number system chart. Okay. So beta, here I will discuss complete information about the number system. Okay. So basically, yeah, the largest number is a beta complex number. Okay, the largest number is a complex number. So this is complex number. So complex number is represented by Z. Complex number is represented by Z. Complex number has two types. Okay, complex number have two types. Has two types. First one is real number, and another one is imaginary number. Imaginary number. Okay. So complex number has two types: real numbers and imaginary number. So real numbers are represented by capital R, and imaginary numbers is represented by I and a small m. Okay. So the real number has two types. Has two types. First is rational number. Rational numbers are represented by Q, and another one is irrational number. And irrational numbers are represented by Q dash, yeah, Q bar, yeah, QC. Okay, so C stands for complementary. Okay, guys, C stands for complementary. C stands for complementary. Complementary. Okay, so after so next, rational number has two types. First one is integer. First one is integer. Integers are represented by capital I or capital Z. Another one is fractional number. Okay, fractional numbers. Another one is fractional numbers. Okay, then after integers are has three parts. Integer has three parts. First one is positive integer. Positive integers are represented by I plus yeah Z plus. Another one is negative integer. I minus yeah Z minus. Okay, and last one is zero. Last one is zero. So one important thing is that beta, all the positive integers, okay, all the positive integers means what? Positive integer means what, beta? Positive integer means positive number. Okay, got it now?
Yes, sir.
Ajay, got it?
Yes, sir.
Positive number is a positive integer means what? Positive number. And positive number means what? It is effectively a counting number. So positive integer is nothing. It is the beta effectively a natural number. Okay, and whenever natural numbers meet with zero, it's generate the whole number. So that is the bit of brief level story about the complex number system. Okay, so that is the fundamental observations. Okay, of the complex number. So just to consider one. Once, just tell me everything is fine now. Have any doubt here, beta?
No doubt, sir.
Okay, wait, thank you. Yeah. So I'm just giving you give you a brief introduction about the complex number, because complex number is a very huge chapter of your class 12. So no need of any worry. In the after the completion of calculus, then I will start the topic called complex number. So right now I'm just giving brief introduction about the complex number. So what is the sense of complex number? What is the complex number? Okay, but that is the formal definition here and the formal introduction about the complex number. But in the chapter called complex number, I will discuss each and everything. Okay, so a number of the form, a number of the form, a number of the form a plus iota b. Beta, I stand for iota. Okay, I stand for iota. So a number of the form a plus iota b is called a is called a is called a complex number. Is called a complex number. Okay, where a and b belongs to real number, and iota is equal to under root of -1. Iota is equal to under root of -1. Okay, and the complex number is usually complex number is usually denoted by z and and the and the set of complex number, and the set of complex number is represented is represented by capital C, Hence we can write in the set builder form. Hence complex number is equal to a plus iota b such that a and b both are the real number, and iota is equal to under root of -1. Iota is equal to under root of -1. Okay, so one important thing is that, guys, I'm just discussing with you, and I think you are also understood the thing properly. So it may be noted that it may be noted that natural number is the subset of, okay, do you know subset? DM, do you know subset, beta?
Yes, sir.
Okay, so natural number is the subset of whole number. Whole number is the subset of integer. Integer is the subset of rational number. Rational number is the subset of real number, and real number is the subset of complex number. Okay, so that is the formal basic one important note point. So I will just discuss with you. So okay now. So it may be, okay, noted that, okay, this is for complex number, okay, complex number. So, but this is the natural number. I think this is the natural number. This is the whole number. This is the integer. This is the rational number. This is the real number. And this is the beta complex. So I think this is clear to all. Okay, beta.
Okay.
Okay, so that is clear, beta. So in the complex number, the general form of the complex number is beta a plus iota b, where a and b both are the real part and iota is the imaginary part. So that is the formal thing. So I will just discuss it, but no need. I'm already this, but I already asked you in the topic in the chapter of complex number. I will discuss very deeply. Okay. Important observation. About the complex number. Again, I will just discuss some important observation about the complex number. Again, so complex number in the form of number in the form of number in the form of a plus b iota. Okay, so a plus b iota is the general form of a complex number, guys. Okay, now where a and b are real number. A and b are a real number is called is called is called complex number. Is called complex number. Okay, is called complex number. It is denoted by it is denoted by it is denoted by z, that is that is z is equal to a plus iota b. Z is equal to a plus iota b. Okay, a is called, very important point, very important point. A is called a is called as a is called as a real part of z, a real part of z, which is denoted by which is denoted by r e r e z. Okay, which is denoted by this is r e z, and and v is called imaginary part of z, imaginary part of z. Okay, imaginary part of Z, which is denoted by I am Z. Okay, I am of Z. Okay. And one important point is that is very important point, that is the rememberable point. Any complex number is any complex number is is first purely real if b is equal to 0. Guys, just consider, if b is equal to 0, iota into b is totally 0 and only a part is available. So purely real if b is equal to 0. Okay, beta. Again,
Okay, sir.
imaginary. So imaginary if b is not equals to 0. But in the case of purely imaginary, but just stress word, purely imaginary if a is equal to 0. That is very important point, beta. Very important, most important point here. If purely real if b is equal to 0, purely imaginary if a is equal to 0, but only imaginary if b is not equals to 0. So that is the beta some important condition of the complex numbers. So I think that is clear. Have any problem here?
No, sir, I'm not out.
Uh, Everything fine?
Yes, sir.
Okay. Next one is points to be remembered. Points to be remembered. So note number 8 first. The set of real the set, let's say the set R, let's say the set R of the set R of real numbers is a is a proper subset of of the the complex numbers. The set R of real numbers is a proper subset of the complex numbers. Hence, the complete number, hence the complete number, hence the complete number system is n is the natural number, is the subset of whole number, is the subset of integer, is the subset of rational number, is the subset of real number, is the subset of complex number. Okay, dude. Okay, that is the first point. First important point. So simply every real number, every set capital R of real number is the proper subset of the complex number. Okay. But do you know something about subset? So beta, subset means that let's say A is the subset of B. So it means that all the elements of A which are present in B. So we can say that A is the subset of B. Okay, dude. All the elements of A which are present in B. So we can say that A is the subset of B. and all the elements of B are present in capital set A, so we can say that B is the subset of A. I think this is clear.
Yes, sir, it's clear.
Okay. Next point is that 0 is purely real. That is very important point. 0 is purely real as well as purely imaginary. Purely imaginary, but not imaginary. Okay, so guys, that is very important point, but I am just putting this statement in the topic called complex numbers. So just to consider this thing, a 0 is purely real as well as purely imaginary, but not imaginary. Purely real and purely imaginary, but not imaginary. Okay, so you are also familiar of this thing. Just consider the condition of imaginary. B is not equal to 0. So B is equal to 0, purely real. A is equal to 0, purely imaginary. But in the case of imaginary, B is not equal to 0. So I think you are also understood what is the theme of this statement. But real analytical proof I will give you in the topic called complex number. So up to your level, you understood. I know very well. But the logical proof and analytical proof I will discuss in the chapter of complex number. Okay.
Yes, sir.
Next, C part. But the iota is equal to under root of -1. Okay. Okay. Is called the is called the is called the imaginary unit. Is called the imaginary unit. Okay. Also, iota square is what? -1. Iota cube is what? Just tell me, beta, iota cube is what? Ajay, iota cube is what? Iota cube is what? So iota cube is iota square into iota. Okay. So iota square is -1. Okay. Iota square is -1. So this is -1 into iota. What? Simply minus iota. Okay. So clearly we can say that iota square is equal to, sorry, iota cube is equal to minus iota. Okay. And iota to the power 4. Okay. So that is because simply iota square into iota square -1 into -1 is +1. So in proper manner, I'm just writing here systematically. Iota is equal to under root of -1. Iota square is -1. Iota cube is minus iota, and iota to the power 4 is simply pi. So that is the formal considerable thing of your. Okay, beta. This is clear now.
Yes, sir, it's clear.
Okay. Right, number D. Under root of A into under root of B is equal to under root of AB only if at least if at least one of A or B is non-negative. Is non-negative. So under root of AB is only under root of AB is equal to under root of A into under root of B is equal to under root of AB only if at least one of A or B is non-negative. Okay. So you are also familiar of that non-negative is what positive plus zero. Yeah. So one of A or B is positive. Yeah, you can say that one of the A or B is also negative. Okay, but
Yes, sir.
that's clear. One important point. So I think we try to understand, just try to understand the things. If Z is equal to A plus iota B, then 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 A minus iota B, A minus iota B is called is called is called complex conjugate. Is called complex conjugate of Z and written as and written as Z bar is equal to A minus iota B. So that is simple, guys, and no need of any tension. Simply Z is equal to A plus iota B, so Z bar is A minus iota B, and both are the conjugate to each other. Simple and nothing else. Okay, okay, beta.
Okay, sir.
Uh, yeah. So that is the beta a node point of the complex number. So simple information and static information. So just 1 minute. I'm just discuss conjugate of a complex number. Don't worry. I'm just discuss one important point. I'm just clearing you. Conjugate. Conjugate of a complex number. Conjugate of a complex number. So basically, basically, conjugate of a complex number. Conjugate of a complex number. Complex number Z is equal to A plus iota B. Z is equal to A plus iota B is denoted and 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 defined by Z bar that is equal to A minus iota B. In a complex number, in a complex number, if we decide, if we replace, if we replace iota by minus iota, we get conjugate of the complex number. So guys, I'm just writing everything on your notebook, on your screen. That's why with no facing any problem. Any complex number, full stop. So finally, Z bar is the mirror image. You can say that Z bar is the okay mirror image of of Z about real axis. Real image of Z about real axis. Real axis on XY plane, but in the topic called complex number, we can say that Argand's plane. Okay, Argand's plane, XY plane, but in the chapter of complex number, we can say XY plane not. We can say Argand plane. Okay, so basically, beta, the thing is that early in the 19th century, Carl Friedrich Gauss and William Roman Hamilton independently and almost simultaneously proposed idea of defining complex number as ordered pair of real numbers. Okay, so simply you are also you can simply say that the a plus iota b is equal to a comma b to each complex number. This corresponds to one and only one point in plane, and conversely to each point in the plane there corresponds one and only one complex number. Because of this, we often refer to the complex number Z as the point Z. So I'm just discuss with you, but no need to think. Just some briefing introduction about it. But just it's enough because in the chapter of complex number, I'm just discussing with you. That's up to your basic level. That's too much enough. Okay, so no need to entertain anything. Okay, beta.
Okay, sir.
So you're up to your basic fundamental thing. That is totally up to the mark. Totally up to the mark. But the next thing, actually, on the level of, I will just discuss. Don't worry. In the chapter of complex number, I will discuss each and everything proper manner. Okay.
Okay, sir.
Okay. So that is clear. So next topic is a twin prime number. Next topic is twin prime number. So basically, the let's say in between of two prime the numbers which have differences to two prime numbers which has differences to are called twin prime. So you can say that the difference between two prime number is two, then we can say that this is called twin prime number. So if the difference if the difference between two prime number difference between two prime number is 2, then they are called twin prime numbers. If the difference between two prime numbers is 2, then they are called twin prime numbers. So I think that is clearly. So this is between 3, 5. Okay, 5, 7, 11, 13, 17, 19, etc. etc. So the difference between two prime numbers is 2. These numbers are called beta simply twin prime numbers. So I think beta this is clear now. Ajay,
Yes,
that
sir.
is
It's
clear
clear.
now.
Yes, sir.
Clearly now.
Yes, sir.
Okay. Do you know something about a rational number? Do you know something about rational number?
Rational number.
Yeah.
Yes, sir. Yes, sir.
What is the definition? Just tell me.
So rational numbers are like, how do I explain? Uh, it's like a fraction, sir.
Yeah, yeah. Good, good. So a number which can be written in the form numerator upon denominator, something, something. So the thing is that now a rational number, the origin is just considered. Just to consider the words ratio. Okay. It is the words ratio. So rational number origination is ratio. Ratio means what? Ratio means beta simply numerator upon denominator. Okay. Ratio means what? Numerator upon denominator. This is the ratio. Numerator upon denominator. That is the ratio. Okay. So numbers numbers which can be written written in the form of p by q. Okay, p by q means what? Numerator upon denominator. P by q, where p and q both are integer, where p and q belongs to integer, and also note if denominator never be zero, because whenever denominator becomes zero, function is undefined. Okay, so set of rational number is is denoted by capital Q. So set of rational numbers is denoted by capital Q. So fundamental example, let's say beta 2 by 3, 11 by 11 minus 1, 0, 0 by 2, under root of 4, etc. Okay. So that is the complex, that is the rational number. Yeah, one important point I'm just writing here, and I'm also explaining this point. Point is very important. All terminating decimal number, all all terminating decimal numbers, all terminating decimal numbers, non-terminating, non-terminating, but but repeating decimal, but repeating decimal, but repeating decimal number is number is numbers are all terminating decimal numbers, non-terminating but repeating decimal numbers are a rational number, or a rational number. So that is the brief introduction. So that is clear, Abita. Anything doubt here? That clear?
No,
Okay,
sir.
just
No doubt.
note it down.
It's up here.
Note it down. Note it down. Done.
Yes, sir. I'm done.
Yeah.
Yes, sir.
Okay. One important point. Important point is that beta 0 upon any number, 0 upon any number is equal to always 0. Okay. So fundamental example, 0 by 2 is equal to 0, 0 by 1 is equal to 0, 0 by 7 is equal to 0, 0 by 11 is equal to 0. But a student asks to me every time, sir, what is the value of 0 by 0? What is the sense of 0 by 0? That is very important. So, beta 0 by 0 is, beta, guys, just Ajay, what is the value of 0 by 0? Just tell me once.
Sir, it's undefined.
No, no, that is not undefined. Yeah, you can usually say undefined, but 0 by 0 is indeterminate. What beta? Indeterminate.
Indeterminate.
Indeterminate. Indeterminate. Okay. So that is clear. Huh? Yeah. Next thing is that any number, any number, any number divided by 0, 0 is equal to what? Undefined. Undefined. Okay. Someone is asking me 1 by 0 is equal to infinite. But that is the wrong thing. Okay. Wrong. Okay. 1 by 0 is not infinite. That is wrong. Okay. Someone is asked 1 by infinite is equal to 0. That is wrong, beta. That is wrong. Okay. So
Okay.
there are very important points. 0 by 0, infinity by infinity, infinity minus infinity, 0 का power 0, infinity का power 0, 0 into infinity, and 1 to the power infinity. 1, 2, 3, 4, 5, 6, 7. Beta, this is called 7 indeterminate form. Okay. No one can define this. Okay. This is called 7 indeterminate. 7 indeterminate form. Okay. 7 indeterminate form. So no one can define the value of this thing. Okay. So that's why we can say that this is called indeterminate form. I think, beta, this is cleared up. That is
Yes, sir.
clear.
It's clear.
Okay. One important thing is that here, let's discuss with you. But I just note it once. Just note it. Okay, beta, done. Ajay,
Yes, sir.
done now.
No, sir. No, sir. I'm still writing.
Okay, ask me. Just write everything. This and this
Yes,
also.
sir.
This is done
Yes,
now.
sir. This I finished.
Okay.
Yes, sir. I'm done.
Okay. So, beta, any doubt up to here? Anything else? Any problem?
No doubts, sir. No.
Okay. So, Ajay, you are in class 12th now, right now?
Yes, sir. Yes, sir.
Yes. Yes. Okay. Yeah. Because just open your video, beta. Just open your camera.
Okay.
So, right now in class, you are in right now class in 12th now.
Yes, sir.
Okay. So, in which school, beta?
I'm in Birla Open Minds.
Birla Open Minds. Okay. Okay.
Yes, sir.
Where? In Chennai, where, beta? Where location?
I'm not living in Chennai right now. I am currently living in Hyderabad.
Oh, right now you are in Hyderabad.
Yes, sir.
Okay. Okay. Right
I
now you are
used
in
to live
Hyderabad.
in Chennai for 12 years before I shifted here.
Okay. Okay. Right now you are in Hyderabad, na? Okay.
Yes,
Okay.
sir.
It's very nice. Very nice. So what's the goal, beta? What's
Sir,
your goal?
I took MBPC, so my main goal was to either enter in marine biology, and if that isn't like uh, well suited out for me, I'm thinking of going into engineering.
Okay, okay, no problem. No, very good thing, beta. So, beta, just to follow my notes properly, okay, that is up to the advanced level. Because I'm also at the top. I have also nearly 10 to 11 year experience in top institute in Kota. I'm also BTech from IIT Madras. So I will handling to you properly and I will manage everything properly. I will have to focus on the study properly and have any doubt, just consult me personally. I think
Okay, sir.
you have also my WhatsApp number. So anything else, but anything doubt, any problem, just consult me personally. And every time I'm just helping you. And you are only one student in my lectures, but no need to worry. I will cover every syllabus and I will cover full syllabus properly. Okay. So everything hopefully very well done. So thank you for today. Just be. Acha, do you want to take one lecture tomorrow? Are you free tomorrow?
Tomorrow, no, sir, I have other classes tomorrow.
Anytime, are you free? Anytime. For only 1 hour. Okay, no problem. No problem. No problem. Okay. So thank you, Ajay. See you next lecture. Okay. Thank you.
Yes, sir. Thank you. Have a nice day.
Um,